Awesome. Okay, so in the last mini lecture, we defined what competition is, and now we're going to delve into two sort of classes of competition. So I bet you're getting the impression that ecologists love classifying things and giving them definitions, and this is not any different in competition. We have sort of two broad classes your book talks about. The first is exploitation competition, and the second is interference competition. One and two. Um, Exploitation competition is indirect competition, right? These are species competing for a shared resource pool that is zero sum, meaning that when one species takes some of that resource out of the pool, there is less available for the other species. But they're not directly fighting with each other, right? This isn't chasing each other out of habitat. This is simply using the same limited resource pool. And this is driven via resource depletion. So this is sort of zero-sum process, meaning that if I take some, my competitor gets less. And this is driven by resource depletion. Cool. Does that make sense? Alternatively, interference competition is direct competition. Here, let's write indirect under here. Is direct competition. This is, for example, male scrub jays competing for nesting habitat and territories. This is voles chasing each other out of, aggressively chasing each other out of prime habitat. Ant colonies attacking each other over shared resources there, right? Plants also do interference competition, right? This is plants growing over top of each other to get light. So these are direct competition, where one competitor is directly blocking the other, right? So exploitation comp, one way to think of this is I use the resource so there's less for you. Interference competition is I directly stop you from taking that resources, right? There's some cool examples in your book of all of these. One of the clearest ones, I'm going to talk about plants here because your book does a good case study here, of exploitation comp, is the evolution of carnivory in plants in really nitrogen poor environments, right? So, nitrogen is a critical part of life on Earth. It's in amino acids. Plants need it. It's one of the most limiting resources for them. And in really low nitrogen environments, carnivorous plants have evolved the adaptation of using external sources of nitrogen rather than from the soil, right? They consume insects. So here, there's a shared pool, let's put carnivorous plants, shared pool of nitrogen resources. And when one plant uses more nitrogen, there's less left for all of the competitors. And this drives the evolution, or we think this drives the evolution of carnivory for external sources of nitrogen. Interference comp in plants, on the other hand, you might think of them as not as dynamic, right? Plants are standing still; they can't chase each other away from resources. But one of the coolest examples, your book talks about kudzu, but I like to think about lianas. You know, we live right at the edge of the neotropics, and lianas, which are these woody twining vines, are extraordinarily abundant and diverse here in the tropics. And lianas grow up trees and physically overtop them and grow their leaves on top of the other plant and take light from them. And I wanted to show you guys a really neat review here. So this is a paper um, from Stefan Schnitzer and Franz Bongers, and they're talking about the sort of general role of lianas in the ecology of forests. But one of the neatest things from this paper that I found was a table looking at liana diversity and how it changes across latitudes. And what the scientists found is that lianas are much more diverse and account for a much larger portion of plants in the tropics than they do in temperate regions. Let me show you this. So here are these data. So this is the proportion of species. So we're not talking biomass, we're talking diversity. And as you can see, the proportion of woody species in forests from the temperate zone to the continental tropical zone goes up fivefold, whereas diversity in trees, for example, may double, triple as we move to the tropics. The diversity of lianas, heptuples or whatever the name for that is, right? So these lianas are cool because they're literally doing direct competition with their structural hosts and taking light from them. In this case, that light is being directly taken via direct interaction between the liana and its host. So competition's not always a fight, right? Sometimes it's the ecological consequence of sharing something scarce, and in that case we call it exploitation comp. And in other cases it is a fight. It's a direct fight between two species of predators for a given prey, like between a vulture and a wolf for prey. And in that case, we call it interference comp. Cool. Okay, stick around for the next mini lecture.